Alright, so we've learned all this stuff about graphing a polynomial. Let's now actually do some graphs. Alright, so I've got 4 steps here. First, we're going to find the zeros, their multiplicities, and whether they cross or touch at those zeros. We're going to find the Y-intercept. We're going to find the end behavior and the max number of turning points. And then we're going to use all that to draw the graph. Okay, so let's start with step 1, which we did in the last video. So recall, in the last video, to find the zeros and their multiplicities and whether they crossed or touched, I made a little chart. So let's make a chart here. So first 0, opposite of our -3 is +3. Multiplicity, well, the multiplicity there is 2. Remember, if it's even, they touch. All right. And then our second 0, opposite of our +2 is -2. No exponent listed there, so it's a 1. And remember, if it's odd, then it crosses. All right, so now let's go to step 2. I've got my zeros, I've got my multiplicities, I've got whether they cross or touch at those zeros. All right, let's find the Y-intercept. To find a Y-intercept, we always put 0 into x, just as we did when we were finding y-intercepts with our quadratic functions. So let's put 0 in all of the x's. Oops. All right, so let's notice here, I'm really going to have in this first set of parentheses -3 squared. So that's going to be 9. My second set of parentheses is going to be 2. So my y-intercept is at 18. Okay, now, got my y-intercept. Let's go to step 3. Find the end behavior and the maximum number of turning points. Now remember, to find the end behavior, we want to think of what things are multiplied out. We've got an x squared and an x to the first. And adding those together, that's going to give us x to the third. So our leading term is going to end up being x to the third. And of course, that has end behavior like x to the third. If we draw x to the third, normally x to the third looks like this. So up on the right, down on the left. Now let's translate that as, on the right, as x, whoops, that was weird. X goes to infinity. Y is up, going up. So y goes to infinity. On this side, on the left, we are down. So left is as x goes to -infinity. And down is y goes to -infinity. So there's our end behavior. Okay, maximum number of turning points is going to be 1 less than our degree of our leading term, so 2 turning points. And now we'll graph this thing. Okay, so I'm going to go ahead and make a graph over here. I know my graphs aren't perfect. And the first thing we're going to do is take our 2 zeros and we're going to mark them on the x-axis. So I have a 0 of 3. 1, 2, 3. There's my first point. I have a 0 of -2. 1, 2. There's my second point. Now, let's go to the y-intercept. I have 0, 18. Now, the truth is that's the only point that we're going to mark on the y-axis. So if we want to, we can just say this is 18 up here. That's where I'm going to put it. I don't have to be perfect at all with this. All right. Now, so now we're going to look at our end behavior. And you can choose to look at the symbols if you like. I think it's easier to look at the little picture we drew. On the right side, I want the graph to go up. So here's my rightmost point. I want to, from that rightmost point, have it going up. All right, on the left side of the graph, I want it to go down. So go to your leftmost point, which is this one, and let's go down. All right, now let's go back to the touching and crossing part. I'm going to start on the left, so I'm going to start at the -2. At -2, we should be crossing the x-axis. That means I have to go across right here. So I don't want it to come back down. I want it to go across. Now, it's got to go up and grab this point. So let's just go up and grab, oops. Erase that a little bit. Try to draw a little bit better. I'm going to go up and grab this point. Now, the truth is, I don't know where it turns around. That's something that we won't learn how to do until calculus. But we'll just kind of draw it turning around because it's got to come back down to the next point. All polynomials continue. They don't have any gaps. So it's got to come down to here. Now let's notice that when we got it right here, we've got it touching at 3. And that's exactly what should be happening at 3. It should be touching. Notice we didn't use the multiplicities in this graph at all. That only told us touching and crossing. All right, now let's notice 2 turning points. So we have 2 turning points. Here's one, and here's one. The graph turns in a separate direction. So there's our graph. All right, so let's take another one through the same sort of steps again. Let's grab this one. All right, so our first step was to find zeros, multiplicities, and whether it crosses or touches. So let's make my little chart: zeros, multiplicities, touch or cross. All right, so first 0. Let's notice there is an x right here, so that 0 is 0. That x has no exponent written there, so its exponent is 1. And so odd exponents always cross. All right, next one. Opposite of our -3 is a +3. Again, no exponent in back of those parentheses, so that's a 1. Odd crosses. All right, so opposite of 4, -4. Again, exponent has to be a 1 out here. And of course, for a 1, it's odd, it crosses. And then our last one is a +5. Again, a multiplicity of 1, and odd exponent crosses. Okay, so we've got step 1. Step 2, let's find the y-intercept. Remember to do that. Put 0 in for x. So we'll have -0, 0, -3, 0 + 4, and 0 - 5. Now the truth is, this 0 out front is just going to multiply times all of these things, so we're just going to get 0. All right, so next, let's find our end behavior. Now let's be careful. Notice this x has a negative in front of it. So we've got a -x, an x, that makes -x² so far, another x, -x³, and another x, -x⁴. So our leading term is going to be -x⁴. Negative in front, even exponent, is an upside down parabola. All right, so let me draw our upside down parabola. Okay, now let's write that in behavior in terms of the homework. All right, so when we go to the right, the graph is going down. So going to the right, we write as x goes to infinity. The graph is going down. Down is y goes to -infinity. And now as x goes to the left, or as we go to the left, the graph goes down. So left is as x goes to negative infinity, and then down is again y goes to negative infinity. There's our end behavior. Now again, it's easier, I think, just to think about the picture as we draw our graph here in a few minutes. Now, maximum number of turning points is 1 less than our exponent here, so 3 possible turning points. All right, so we've got all 3 of our previous steps. Now let's go to the graph. I'll just put the graph over here. First thing we do is we put our zeros on the graph. So 0, so right there at x equals 0 is my first one. 3, 1, 2, 3. Negative 4. 1, 2, 3, 4. There's my third point. And positive 5. Let's see, that was 3, so 4, 5. Here we go. All right, now we graph our y-intercept. Well, the y-intercept is 0, 0, which is that point right there. So we don't have to put that on there. That's already there. Now let's go to end behavior. Down on the left, down on the right. So let's go to the far right, and we want it to go down. Let's go to the far left, and we want it to go down. Okay, now we need to pay attention to our touching and crossing. Let's notice that no matter what, we've got crossing. So we come up to this point, we want it to cross. So it's got to go across the x-axis, which means it's got to come back down to hit that point right there. Now, it might rise higher, it might rise even lower. You don't have to be perfect about how high we come up. All right, now it crosses again. So cross the x-axis. Well, that means it goes down and it's got to come back up to its other point again. All right, and we know that it crosses there too. So it's got to go up and it's got to come back down to the last point. And of course, it already crosses. All right, now let's notice 3 turning points. Well, there's 1, there's 2, and there's 3. So we're good.